Today I want to talk about making predictions in ANOVA. This is a short tutorial about how to sort of start thinking about it. In our study and the Needles project, there's really two different ANOVAs that we can look at here. One of them is low and high, and then we have north facing and south facing. And then the other one we have is south and north with no mistletoe, we just put mistletoe here and no mistletoe here. Okay, so this is kind of what the data that you have you can look at so far in this first Needles lab. And what I want to do is draw out some predictions. I think this is worth doing. It's just worth thinking about, do you understand how this stuff works? And can you conceive ahead of time a multifactorial explanation for something? And that means that the interaction effect, how's it going to look? So let's take a look at the first thing down here, which is a main effect. If drought stress causes shorter needles, then needles on trees at low elevation, where it is hotter and drier, will be shorter than high elevation needles. Okay, so we're just looking at low and high. So this is really a main effect of between this group and this group. Remember, pooling all those together. What would that graph look like? If our hypothesis is true, then we will have low elevation and high elevation looking like this, and this is length, right? So easy to draw, right? You could put dots on here if you want and draw a line like that. That's the relationship. The next one, and it's key here that I'm thinking that this whole system is based on this drought stress idea, which could be wrong. And it's okay. If it's wrong, I think the data is going to tell us. The next one would be, this is a main effect, right? And this is a main effect down here. If drought stress causes shorter needles, the needles facing south on trees should be shorter than needles facing north because south-facing needles receive more sunlight. Okay, pretty straightforward. I can draw that graph too. All right, it looks very much the same. South, north, length. All right, so this is all me predicting what stuff's going to look like before I've even seen the data. All right, now about the interaction. If drought stress exceeds a critical threshold at low elevation, let's just tell this. So now I'm looking for something that really what I'm thinking here is that at low elevation, not only is it hot and dry because it's low, but it's also hot and dry because it's south, and that is going to hammer these things, and I'm going to see a disproportionate effect of southness of needle length, right? It'll be really low. So let's take a look. If drought stress exceeds a critical threshold at low elevation, then needles from south-facing low-elevation trees will have a disproportionately shorter needles compared to south-facing high-elevation trees. In other words, the effect of being on the south side will depend on the level of elevation. So that's great, right? So let's take a look at how that will look. Probably in your graph, because you're using Jamovi, you'll get two bar graphs. I'm going to do this very carefully. I'm going to put the low group here and the high group here, and then I'm going to put the south-facing. It's going to have a huge effect at low elevation and a small effect at high elevation. So south, north, south, north. Now what you should be able to see from, did you see how I did that? That was kind of slick, I think. Notice that the difference here is really big, and the difference here is really small. Both of them have a negative effect of being on the south side, but not the same amount. If I want to, I can draw lines between these things like this and like this, and you can see that these two lines are not parallel, right? They essentially look like this and like this, right? So not parallel lines. So what that means is the effect of being on the south side is different at low elevation than it is at high elevation. Another way of saying that is the effect of being on the south side depends on what elevation you're at. It's a small effect at high elevation and a large effect at low elevation. Yeah, okay. You could also reverse that, and you could say that the effect of elevation is dependent upon what side of the tree that you're on, which would be a different drawing. And we could do it that way. Ooh, I know at some point this just becomes shenanigans, right? So let's try it that way, where I put south on this side, and I put north on this side. And now on the south side of the tree, I'm going to see that at low elevation, I have a really negative effect. But at high elevation, I have... Oh, this is harder to draw. South, north, at a high elevation, it's pretty long, right? So the south side of the tree was there, and on the north side of the tree, it's going to be a small effect, essentially. So this is going to be high, high elevation, and low elevation, and this will be high elevation and low elevation. So you're still seeing an effect of being on the south side, right? Still has a negative effect of being on the south side because the mean of these two is down in here somewhere, right? That's your x bars right in there. And the other one is going to be a little bit higher than that. It's going to be up here, right? The main effect of north and south is still significant, but you can see that proportionally the difference between elevations is bigger when you look at it on the south side. Whew. So we could draw lines between these two. It looks the same. All right. So this is how you might cartoon out your predictions. I recommend you do that because, oh, you know, this data is crazy and it's not going to look like this. And you're probably going to get surprised and you're going to have to deal with that. There are some other hypotheses. Some people have hypothesized that light is the limiting factor for needle growth. And while I think it might be unlikely in a desert, it is a reasonable hypothesis. So you can play it out and see how you would affect think elevation would affect that. And people have talked about growing season length and how that would affect it. Because maybe it's colder at high elevation and there's a shorter growing season than at low elevation. People in class mentioned competition being different at high and low. So all these different things, but you probably want to cartoon out your own prediction. So thanks for tuning into this one.